Time of flight. What about the definition of the time of flight? We already completed time of ascent, time of descent. What is time of ascent and time of descent? Time of ascent is nothing but a time taken by the body to reach maximum height, that is time of ascent. And time of descent is nothing but a time taken by the body to reach ground from maximum height, that is time of descent. So time of flight is equal to sum of the time of ascent and time of descent is called time of flight. So time of flight is equal to sum of the time of ascent and time of descent is called time of flight. And time of ascent formula is u by g. Time of descent is equal to u by g. Then you can write time of flight is equal to 2u by g. Time of flight is equal to 2u by g. Okay, this is about the time of flight. Next one we can discuss velocity at half of maximum height. Velocity at half of maximum height. See here, when object is projectile upward direction, at that moment, what about the, for example, this is the maximum height attained by the object. This is maximum height attained by the object. Now exactly half of maximum height. Half of maximum height means this distance s is equal to, we can write half of maximum height. H maximum, this is H maximum, isn't it? Object is projectile upward direction. The object is gradually going upward direction like this. So here velocity is 0. When velocity is 0 meaning, that means it attains the maximum height. So from here to here it is maximum height. Now exactly half of maximum height. At this position if you take an half of maximum height, how we can know? We don't know, that is just we are assuming. For your understanding I am telling you, from here to here it is 100 meters. From here to here it is 100 meters. Half of maximum height means exactly midpoint at a 50 meters height. At 50 meters height, what is the velocity? We have to calculate it. What is the velocity? How we can calculate that one? Don't use this 50 and 100, just for your understanding I have given. Now how you can write? Half of maximum height means, see here, u is equal to initial velocity. The object is projected with the initial velocity is u, and final velocity v is equal to 0. But I am not taking from here to here, just we are considering here only. Here final velocity we know very clear, 0. But at this position it is having some velocity. When velocity is 0 means here only the object will fall from here only, but the object is going up to here. So here what is the velocity? V I am calculating. This is initial velocity and this is final velocity. We are taking the two situations at A and at B. At A and at B. So u is equal to initial velocity is u, final velocity, initial velocity is u, final velocity is equal to v. Final velocity is equal to v. And acceleration a is equal to minus z, and distance s is equal to h maximum by 2. They are given very clearly, h maximum by 2. Substitute those values in the equation. V square minus u square is equal to 2s. V square minus u square is equal to 2s. Final velocity is v, isn't it? V, and minus u. U is nothing but initial velocity, 2as. And here h maximum, we calculated maximum height. H maximum is equal to u square by 2g. Can you remember? Just now only we calculated h maximum is equal to u square by 2g. Substitute in this situation, u square by 2g into 2, that is nothing but a 4g. I am substituting. S is equal to u square by 4g. U square by 4g. Is it? 2 1s are, 2 2s are. We can get calculation after calculation. v square minus u square is equal to v square minus u square is equal to a into, this is a equal to minus g, a equal to minus g, so I am writing this is minus g and 2 already cancelled, minus g u square by 2g, g also get cancelled, u square I am taking that side, v square is equal to u square by 2, the minus is there, minus if you take that side plus, isn't it? And what about the LCM here? LCM is 2, minus u square plus 2u square. We can get u square by 2, v square is equal to u square by 2. Square if you take on that side, v is equal to under root of u square by 2. Square root get cancelled here, v is equal to u by root 2. V is equal to u by root 2. So at the half of maximum height, what is velocity attained by the object means v is equal to u by root 2. That v equal to u by root 2. Okay. When you consider air resistance taken in account, means when object is going upward direction, see here, when object is going upward direction, I told you, when object is going upward direction, what about the velocity of the object is gradually decreasing. How it is decreasing? Simple manner, if there is any opposing force, at that time only velocity can decreases. Who are opposing? Not myself, not yourself. When object is going upward direction, air resistance force is opposing this one. So R is nothing but a air resistance. R is nothing but a air resistance. R is nothing but a air resistance force, isn't it? So I am giving this one. When object is going upward direction, weight of the object is acting downward direction. Air resistance force is opposing that motion. So force F is equal to mg plus R. Resultant force is equal to both forces are acting downward. So that's why mg plus R I have written. At that moment, F is nothing but a ma. F is equal to ma. Actually, you can write G also, but here we are writing G now. So that is G dash you can mention. No problem, that is also. You can write it is ma. So ma is equal to mg plus R. M if you take in this side. For your further clarification, if you don't mind, I can write this is mg dash. F is nothing but a mg dash. Because acceleration, we can up and down, we cannot call this is nothing but a acceleration. So F is nothing but I am writing it is the mg dash. M if I am taking this side, g dash is equal to g plus R divided by L. G dash is equal to G plus R by L. What about time of ascent? When object is projected upward. Means time taken by the body to reach maximum height is called time of ascent. Now here object is going upward means we have to consider that is time of ascent. So time of ascent is equal to, we know formula U by G. But here that is I am writing as a G dash. Time of ascent is equal to I am writing as a U by G dash. G dash is equal to, substituting this equation, TA is equal to U divided by G dash is equal to G plus R divided by M. G plus R divided by M. This is time of ascent. Time of ascent is equal to. Okay. Time of descent means when object is falling downward direction. See here object is going upward direction. Here object is moving downward direction. What about air resistance? Air resistance means, always you have to remember, resistance means opposing. See here, when object is going upward directions, resistance is downward, because when object is going upward direction means opposing force should be downward, isn't it? Now when object is moving downward direction, opposing force should be upward. So resistance force is upward. Weight of the object is downward. Weight of the object is downward. So resultant force. Resultant force I am writing as a mg minus r. Why I want to write mg minus r only? Why cannot write r minus mg? Why cannot write mg minus r minus mg? Because the object is moving downward direction. Object is moving downward direction means in this situation downward force is greater than upward force. Downward force is greater than upward force. So resultant force is nothing but a greater force minus lesser force. Here greater force is nothing but a mg, lesser force is nothing but a r, isn't it? So mg minus r only we have to write, not we should write r minus mg, isn't it? Greater force minus lesser force. The object, for example, if object is going upward, these two are reverse means you can write r minus mg, because always resultant force means it is nothing but an unbalanced force or unbalanced force. Unbalanced force, how we can write? Greater force minus lesser force. Here, how you know this is mg only greater force? How do you know? You have to question here. How do you know this mg only greater force means? Because the object is going downward, not upward. Going downward means this force is down greater than the opposing force. So this is mg double dash I am writing, because here mg dash I have written. So this is mg double dash I am writing. Mg minus r. M if I have taken this side, g double dash is equal to g minus r divided by m. Now in the time of descent, when object is falling downward, that is time of descent. Time of descent is equal to u by g double dash. Actually u by g only, but here symbol g double dash is there, so that's how we given. Td is equal to u divided by g double dash is equal to g minus r divided by m. This is time of descent. Time of descent means object is moving downward direction. Time of ascent means object is going upward direction. The ratio time of ascent divided by time of descent is equal to, time of ascent means u divided by g plus r divided by m whole divided by, time of descent is nothing but a u divided by g minus r divided by m. U get cancelled. This denominator goes to numerator. G minus r by m is nothing but a denominator's denominator. So it goes to numerator. At that moment, time of ascent is equal to time of descent is nothing but a g minus r divided by m divided by g plus r by m. This is ratio of time of ascent, time of descent when a resistant force is taken account. Okay. Now we are taking one building or tower, whatever it may be, isn't it? From this one, just I am taking it is a one building. Okay. From this building, one object is dropped. One object is dropped from the, it is first object. One object is dropped from the top of the building, and another one person it is at bottom. One object is projected upward direction. It is the second object. Simultaneously, one object is dropped from the top of the building, and from the bottom, at that moment one person it is object is projected upward direction. In an equal time interval, they will meet. In equal time interval, they will meet. Now we have to calculate two objects meet after t seconds. Two objects will meet after 2 seconds. Now how it is means, see this situation. One object is falling downward direction, it is covered, and when object is going upward direction, isn't it? At this position, these two objects are meet. At this position, two objects are meet. Now from here to here, time distance is nothing but I am writing S1, and from here to here the distance I am writing as a S2. From top to here and from bottom to here, just these are nothing but a distance. From here to here it is S1, from here to here it is S2. First I am considering case 1. Case 1, Case 1 is nothing but the object is falling downward direction. When object is falling downward direction, initial velocity is 0. Initial velocity is 0. So u is equal to, we are writing 0 initial velocity. How much distance it is covered? How much distance it is covered? That is s is equal to s1. From here to here distance is nothing but s1. But I told you just now only, the vertical displacement we can call it is height. So it is vertical displacement. So instead of the s I am writing this is h1. This is s1 and this is h2. So vertical displacement s1 is equal to, I am writing h1. From the equation, third equation of the second equation of the motion, s is equal to ut plus of at square. S is equal to ut plus of at square. Here s is nothing but a, how much distance it is taken place? h1. So that is h1. And what is initial velocity? Initial velocity of the object is 0. So 0 into something is 0, I am writing, plus of, what about acceleration? When object is falling downward direction, acceleration we can call it is acceleration due to gravity. A is equal to g, we are writing. A is equal to g. Okay. Then time is equal to t square. They given already in the case, two objects meet after t time interval. Means it is traveling from here to here it is t, and from bottom to here it is time interval is t. The time interval is same. So I am writing for this one it is t. H1 is equal to of gt square. That is equation number 1. In next situation, the object is projectile upward. When object is projectile upward direction, here initial velocity, case 2 is an initial velocity is u, because without giving any velocity the object cannot go. So there is a initial velocity. Now height, how much distance it is travel? S is equal to h2. Acceleration is equal to minus g. See here object is falling downward direction, plus z I taken. Now here from bottom to going up, so direction is changed, so that's why a equal to minus g I have written. Again I am taking s is equal to ut plus of at square formula. Here s is nothing but a h2. S is nothing but a h2. Distance h2 is equal to, u is nothing but initial velocity is u, and time interval already I had given, time interval is nothing but a t, minus a equal to minus z. So minus into plus is minus of gt square. That is equation number 2. Add equation 1 and equation 2. At that moment I am writing h1, equation 1 plus equation 2. Equation 1 plus equation 2, if I am taking h1 plus h2, LHS side, these two are LHS side, h1 is LHS and h2 is LHS. So these two are LHS side, h1 plus h2 I am writing right hand side, these two you have to add. That is equal to of gt square, and this side it is nothing but this equation, ut minus of gt square is there. So plus ut minus of gt square. Here of gt square get cancelled. We are writing h1 plus h2 is equal to h height. See here, this is h1 height, this is h2 height. This, if you add these two, we can get that is nothing but a height of the building. We can get the height of the building. h1 plus h2, that is nothing but it gives the total height of the building. So h1 plus h2 is equal to h I am writing, that is equal to ut. So t is equal to h by u is the answer. After t time interval, after t is equal to nothing but h by, after h by u time interval, these two bodies are meet at this position. After h by u time interval, these two bodies are meet. So that is the equation we given, t is equal to h by u. And next situation, next case, we are writing next case, the time after which their velocities are equal. After what time these two are having the same velocity? See here, after what time interval these two bodies are having same velocity, because one object is coming downward direction. Here initial velocity is 0, 0 to. When object is moving downward direction, what is the velocity? Gradually increasing. When object is, if you take the one object, see here, when object I am taking here, when object is falling downward direction, velocity is gradually increasing. Now when object is projected upward direction, velocity is gradually decreasing. Now these two are at what time interval these two bodies are having equal velocities, they are asking. After what time interval these two are having equal time interval. So we are taking it is first case 1 again. Case 1 is nothing but always I am taking case 1 is nothing but object is moving, falling downward direction, freely falling body. In freely falling body, what is initial velocity? Initial velocity is 0. After t time interval, it is attaining the velocity is v. So initial velocity u is equal to 0. And time after t time interval we know it is nothing but a t, and final velocity is nothing but a v. Final velocity is v, and I am taking v equal to u plus at. From the first equation of motion, final velocity is v, I am writing, and initial velocity is 0. A equal to g, and time is nothing but a t. That is equation number, I am writing v equal to gt. That is equation number 1. Case 2, I am taking case 2. In the case 2, what is case 2? The object is going upward direction. See here, if you give some velocity, this is object, without giving any velocity the object is not going. If you give some velocity only, the object is going. So it is projected with a velocity u. The object is projected with a velocity u. So initial velocity is nothing but a u, and final velocity is v. Why I am taking v means, in the situation, in this case, after what time interval both bodies are having equal velocities. So that's why only here final velocity v only I am taking, and in this situation also I am taking final velocity is v. So distance, next one, it is time interval. Time is nothing but a t. Time interval, it is nothing but a t. Again we are writing equation v equal to u plus at. From this equation v is equal to v, and u is nothing but a u, and a equal to, when object is going upward direction, acceleration is minus g. When object is going upward direction, acceleration is minus g. So a I am writing as a minus g, and this is t. Now this is equation number 2. They said it is equal velocities. V is equal to gt, v equal to u minus gt. So just to compare equation 1 and equation 2. When you compare equation 1 and equation 2, here gt, first I am writing gt, isn't it, equal to, just I am comparing RHS, u minus gt. Gt if you take this side, you can write here gt plus gt is equal to u. gt plus gt is equal to u. Then gt plus gt is equal to u. gt plus gt is nothing but a 2u. 2gt. gt plus gt is nothing but a 2gt, that is equal to u. But in this situation they asked after what time interval. We have to calculate time interval. After what time interval these two bodies are having equal velocities. So t is equal to, we are calculating, t is equal to u by g. So after this time interval, the both bodies are having equal velocities. After this time interval, both bodies are having equal time interval, isn't it? And next one we are calculating what is the ratio. And see here, after t time interval both bodies are having equal velocities, we are saying, but in this time interval how much distance it is travel and how much distance it is travel, that ratio we need it. So for that one, just I am writing what is the ratio of h1 and h2, what is the height traveled. First example, s is equal to ut plus of at square. When object, case 1, again case 1 I am writing. What is case 1? Every time case 1 is nothing but a object is freely falling body. Case 2 is nothing but a object is vertically projected upward. So in t time interval, how much distance covered by this particle? First I am calculating. When object is falling downward direction, in a t time interval, how much distance it is covered. So here s is equal to distance travelled by the body is nothing but a h1, and time interval t is equal to, we already calculated, t is equal to u by 2g. After this time interval only, how much distance it is covered, that we are calculating. And then after t is equal to u by g. If you substitute a equal to plus z, falling downward direction, I told you positive, going upward direction, that is the minus z. Substitute those values in this situation. S is nothing but a h1, s is h1, and u as usual. When object is freely falling body, what is initial velocity? You know children very well. When object is freely falling body, initial velocity of the body is 0. Without giving any velocity. See here, I am not applying any force. Just I leave that one. With initial velocity 0 only, it is accelerated downward direction. So initial velocity, in case 1, object is freely falling body. So initial velocity is 0. U is equal to 0. I am writing 0 into something, 0. Plus 0 into something, that is 0, plus half. A equal to, already that is, we know it very well, G. And T is equal to, we already calculated, U by 2G. I am substituting U by 2G whole square. T square is there, no? T square is there. So that's why T square I substitute. H1 is equal to 1 by 2 G into U square whole square. 2G whole square means 4G square. In this situation, G and G square get cancelled. 2 into 4, 8. So we can get here, H1 is equal to U square by 8G. H1 is equal to U square by 8G. Next one, case 2. Case 2, what is case 2? Object is vertically projectile upward. So without giving any velocity, the object cannot go upward. So initial velocity is u, and acceleration is equal to, already we know it, acceleration going upward or downward, it is upward situation. So acceleration is nothing but a minus z. Acceleration is minus z. Coming downward plus, going upward minus. Now time is equal, after what time interval we are calculating? After t time interval, the t is equal to u by 2g. T is nothing but a u by 2g. We know formula, s is equal to ut plus of at square. Here s is nothing but a h2. Going upward direction, how much distance it is covered, h2. U is equal to u only, and t is equal to, u by 2g. A plus, I am writing 1 by 2. A equal to minus z. T value, how much it is? U by 2g whole square. T square is there, so whole square. Then if you calculate u into u square by 2g, minus into plus, minus, and g into, here g and u square, isn't it, divided by 4, 2 whole square, g square. So 4g square, and one more 2 also there. G square, g get cancelled, isn't it? We can get here 2 into 4, 8. U square by 2g minus u square by 8g. What is the LCM here? LCM, you know very well, 8 into 2, 2 ones are 2 fours are, and 2 twos are, isn't it? So 2 twos are 4, 4, 8 is the LCM. So LCM is nothing but a 8G. LCM is the 8G. Now I am writing it is 4u square minus u square. The resultant is 3u square by 8G. H2 is equal to 3u square by g. But we are calculating ratio. H1 is H2. H1 by H2. So what is H1 is equal to? We got H1 is equal to 8 square by u square by 8g. H1 is equal to u square by 8g. U square by 8g east, and H2 is equal to 3u square by 8g. 3u square by 8g. U square by 8g, u square by 8g get cancelled. Here 1 is there and remaining here 3 is there. 1:3 ratio. 1:3 ratio. How it is means, when object is after t time interval, it is covered 1 here, distance covered 1 meters for example. While it is going upward direction, it covers 3 meters distance. After equal time interval, while it is moving downward direction, 1 meter if it is covered, going upward direction it is covered 3 meters. That's why only H1 is H2 is equal to, see here, H1 is 1, H2 is equal to 3. So 1:3 ratio. When object is projected from the top of the tower or from the top of the building, what is the height of the building? If you want to calculate, how you can calculate? See here, I am taking one building. From this, height of the building is h. Height of the building is h, isn't it? Now, one object is projected from this top of the tower. For example, one student is there on the top of the building. He is projected one stone upward direction. Now, the path of the object is nothing but a parabolic. The object will be travel along this direction. Now, how you can calculate this top of the building at that moment means, the maximum height covered means from here to here distance is x. Then after I am taking this is minus x. Up to here just I am writing this is minus x. Then after this is minus h I am writing. Why we have to write it is minus x minus h? Unnecessarily means it's not unnecessarily. Displacement is the vector quantity. It is changing the direction. See here, from here to here positive direction, and from here to here the velocity is changing the direction every time. When object is projectile upward, this direction is positive. One direction if you consider positive means opposite direction we have to consider is negative. So upward direction if you consider as a positive means downward direction it is we are consider as a negative. So what is the total displacement? Means S is equal to the object to travel from here to here like this. So from here to here it is the plus x, from here to here it is plus x, from here to here it is minus x, from here to here it is nothing but a minus h. In this one, x and plus x get cancelled. We can write S is equal to minus h. Now, with an object is projected with a velocity u. So initial velocity you have to write as a u, isn't it? Now, initial velocity is u. Time interval. Time is equal to t. From here to here it reached. So for that one time is t. And acceleration a equal to minus z. See here the object is going upward. So we have to write minus z. If it is coming downward, plus z. Now take the second equation of the motion. S is equal to ut plus of at square. Now here S is equal to what we got? Minus h. So I am writing minus h. That equal to initial velocity. With what initial velocity the object is projected? U. So initial velocity is u. U means u we are writing. Time is nothing but a t plus 1 by 2. What about A is equal to minus z? A equal to minus z and time is t. minus h is equal to ut, plus into minus is nothing but a minus of gt square. If I apply the minus that side, just if I take the common minus, otherwise here h is equal to minus, I am taking this minus ut plus of gt square. If you know the initial velocity, and time, you can calculate the height of the building. But most of the students, they do the mistakes. Where they do the mistakes means without taking this minus sign. Simply they do the problem s is equal to ut plus of at square. Means s is nothing but a h, u is t, we are writing, object is projected upward. So minus of gt square they do here. But here minus indicates nothing but a minus ut. This is not a correct equation. At that moment, if you assume like this is the wrong assumption. You have to take that equation h is equal to minus ut plus of gt square, isn't it? For example, if you want to calculate time, they given h and u, but they didn't mention about the t. At that moment, how you can calculate the time? Means just I am writing this equation of gt square minus ut minus h is equal to 0, means that is ax square plus bx plus c is equal to 0. This equation in the form of this total is nothing but a and this is nothing but a b and this is nothing but a c. Ax plus b, ax square plus bx plus c is equal to 0. How you can write the formula? X is equal to minus b plus or minus under root of b square minus 4ac divided by 2a. By using of this equation, you can calculate the time. Okay.